welcome to my YouTube channel, where every episode I take a physics topic and really try to explain it in a simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. In today's episode, I will be introducing infrared radiation and black body radiation. So to start, I'll give a little introduction to infrared radiation. All objects are continually emitting and absorbing infrared radiation, and it's emitted from the surface of the object. The hotter an object is, the more infrared radiation it emits in a given time. When you have an object that's hotter than its surroundings, in order for it to cool down, it will have to emit more infrared radiation than it absorbs. When you have an object that's cooler than its surroundings, in order for it to warm up, it will have to absorb more infrared radiation than it emits. Whereas objects at a constant temperature emit radiation at the same rate that they absorb it. And like I said in my colours episode, some colours absorb and emit radiation better than others, just like light. So a black surface is better at absorbing and emitting radiation than a white one, and a matte surface is better at absorbing and emitting radiation than a shiny one. Alrighty, now onto the main event. Black bodies are the ultimate emitters. So a perfect black body is an object that absorbs all of the radiation that hits it. This means that no radiation is reflected or transmitted. So all objects emit EM radiation due to the energy in their thermal energy store. And this radiation isn't just in the infrared part of the spectrum, it covers a range of wavelengths and frequencies. Perfect black bodies are the best possible emitters of radiation. The intensity and distribution of the wavelengths emitted by an object depend on the object's temperature. And, just to note, intensity is power per unit area, so how much energy is transferred to a given area over a certain amount of time. As the temperature of an object increases, the intensity of every emitted wavelength increases. But the intensity increases more rapidly for shorter wavelengths than it does for longer wavelengths. And this causes the peak wavelength, so the wavelength with the highest intensity, to decrease. The curves on this graph show how the intensity and wavelength distribution of a black body depend on its temperature. This is important. Alrighty, so now that you've got that very important graph locked into your brain, I can give you my last little nugget about radiation, which is that it affects the temperature of the Earth. So, the overall temperature of the Earth depends on the amount of radiation that it reflects, absorbs, and emits. Throughout the day, lots of radiation, like light, is transferred to the Earth from the sun and absorbed. This causes an increase in local temperature. Whereas at night, less radiation is being absorbed than is being emitted, causing a decrease in local temperature. So overall, the temperature of the Earth stays fairly constant. However, changes to the atmosphere can cause a change to the Earth's overall temperature. If the atmosphere starts to absorb more radiation without emitting the same amount, then the overall temperature will rise until the absorption and emission are equal again. Ta-da! Thank you for listening! I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.